I'm a doctor, but I kind of slipped sideways into research, and now I'm an epidemiologist. And nobody really knows what epidemiology is. Epidemiology is the science of how we know in the real world if something is good for you or bad for you. And it's best understood, through example, as the science of those crazy, wacky newspaper headlines. And these are just some of the examples. These are from the Daily Mail. Every country in the world has a newspaper like this. It has this kind of bizarre, ongoing philosophical project of dividing all the inanimate objects in the world, really, into the ones that either cause or prevent cancer. So here are some of the things they've said. Cause cancer recently: divorce, Wi-Fi, toiletries, and coffee. Here are some of the things they say: prevent cancer, crusts, red pepper, licorice, and coffee. So already you can see there are contradictions here. Coffee both causes and prevents cancer. And as you start to read on, you can see that maybe there's some kind of political valence behind some of this. So for women, housework prevents breast cancer, but for men, shopping could make you impotent. So we know that we need to start unpicking the science behind this. And what I hope to show is that unpicking dodgy claims, unpicking the evidence behind dodgy claims, isn't a kind of nasty carping activity. It's socially useful, but it's also a kind of an extremely valuable explanatory tool, because real science is all about critically appraising the evidence for somebody else's position. That's what happens in academic journals. That's what happens at academic conferences. The Q&A session after a postdoc presents data is often a bloodbath, and nobody minds that. We actively welcome it. It's like a kind of consenting intellectual S&M activity. So, what I'm going to show you is all of the main themes, all of the main features of my discipline, evidence-based medicine, and I will talk you through all of these and demonstrate how they work, exclusively using examples of people getting stuff wrong. So, we'll start with the absolute weakest form of evidence known to man, and that is authority. In science, we don't care how many letters you have after your name. In science, we want to know what your reasons are for believing something. How do you know that something is good for us or bad for us? But we're also unimpressed by authority because it's so easy to contrive. This is somebody called Dr. Gillian McKeith, PhD, or to give her full medical title, Gillian McKeith. Again, every country has somebody like this. She is our TV diet guru. She has massive kind of 5 series of primetime television giving out very lavish and exotic health advice. She, it turns out, has a non-accredited correspondence course PhD from somewhere in America. She also boasts that she's a certified professional member of the American Association of Nutritional Consultants, which sounds very glamorous and exciting. You get a certificate and everything. This one belongs to my dead cat, Hetty. She was a horrible cat. You just go to the website, fill out the form, give them $60, and it arrives in the post. Now, that's not the only reason that we think this person is an idiot. She also goes on and says things like you should eat lots of dark green leaves because they contain lots of chlorophyll and that will really oxygenate your blood. And anybody who's done school biology remembers that chlorophyll in chloroplasts only makes oxygen in sunlight, and it's quite dark in your bowels after you've eaten spinach. Next. We need proper science, proper evidence. So, red wine could help prevent breast cancer. This is a headline from the Daily Telegraph in the UK. A glass of red wine a day could help prevent breast cancer. So you go and find this paper, and what you find is, it is a real piece of science. It's a description of the changes in the behavior of one enzyme when you drip a chemical extracted from some red grape skin onto some cancer cells in a dish on a bench in a laboratory somewhere. And that's a really useful thing to describe in a scientific paper. But on the question of your own personal risk of getting breast cancer if you drink red wine, it tells you absolutely bugger all, okay? Actually, it turns out that your risk of breast cancer actually increases slightly with every amount of alcohol that you drink. So, what we want is studies in real human people. And here's another example. This is from Britain's leading diet nutritionist in the Daily Mirror, which is our second biggest selling newspaper. An Australian study in 2001 found that olive oil in combination with fruits, vegetables and pulses offers measurable protection against skin wrinkling. So then they give the advice, if you eat olive oil and vegetables, you'll have fewer skin wrinkles. And they very helpfully tell you how to find the paper. So you go and find the paper. And what you find is an observational study, right? Obviously, nobody has ever been able to go back to like 1930, get all of the people born in one maternity unit, and half of them eat lots of fruit and veg and olive oil, and then half of them eat McDonald's, and then we see how many wrinkles you've got later. You have to take a snapshot of how people are now. And what you find is, of course, people who eat fruit and veg and olive oil have fewer skin wrinkles. But that's because people who eat fruit and veg and olive oil, they're freaks, okay? They're not normal. They're like you. They come to events like this, right? They are posh, they're wealthy, they're less likely to have outdoor jobs, they're less likely to do manual labor, they have better social support, they're less likely to smoke. So for a whole host of fascinating, interlocking social, political, and cultural reasons, they are less likely to have skin wrinkles. That doesn't mean that it's the vegetables or the olive oil. So, Ideally, what you want to do is a trial, and everybody thinks they're very familiar with the idea of a trial. Trials are very old. The first trial was in the Bible, Daniel 1:12. It's very straightforward. You take a bunch of people, you split them in half, you treat one group one way, you treat the other group the other way, and then a little while later, you fold them up and see what happened to each of them. So I'm going to tell you about one trial, which is probably the most well-reported trial in the UK news media over the past decade. And this is a trial of fish oil pills. And the claim was fish oil pills improve school performance and behavior in mainstream children. And they said, we've done a trial. All the previous trials were positive, and we know this one's going to be too. That should always ring alarm bells, right? Because if you already know the answer to your trial, you shouldn't be doing one. Either you've rigged it by design, or you've got enough data so there's no need to randomize people anymore. So this is what they were going to do in their trial. They were taking 3,000 children. They were going to give them all these huge fish oil pills, 6 of them a day. And then a year later, they were going to measure their school exam performance and compare their exam performance against what they predicted their exam performance would have been if they hadn't had the pills. Now, can anybody spot a flaw in this design? And no professors of clinical trial methodology are allowed to answer this question. So there's no control. Okay, there's no control group, but that sounds really techy, right? That sounds really, no, that's a technical term. The kids got the pills and then their performance improved. What else could it possibly be if it wasn't the pills? They got older, okay, we all develop over time. And of course, also there's the placebo effect. The placebo effect is one of the most fascinating things in the whole of medicine. It's not just about taking a pill and your performance and your pain getting better. It's about our beliefs and expectations. It's about the cultural meaning of a treatment. And this has been demonstrated in a whole raft of fascinating studies comparing one kind of placebo against another. So we know, for example, that 2 sugar pills a day are a more effective treatment for getting rid of gastric ulcers than 1 sugar pill a day. 2 sugar pills a day beats 1 sugar pill a day. And that's an outrageous and ridiculous finding, but it's true. We know from 3 different studies on 3 different types of pain that a saltwater injection is a more effective treatment for pain than taking a sugar pill, taking a dummy pill that has no medicine in it. Not because the injection or the pill do anything physically to the body, but because an injection feels like a much more dramatic intervention. So we know that our beliefs and expectations can be manipulated, which is why we do trials where we control against a placebo, where one half of the people get the real treatment and the other half get placebo.